23 design patterns, one drawing each. No pizza metaphors, no coffee shop analogies, just the mechanism. What moves, what stays fixed, and what each one actually costs you. Timestamps are in the description. First up, creational patterns. 5 answers to 1 question. Who decides what gets built? 3 callers ask for the config. The first call constructs it. Every call after gets that same object. A second one never exists. It's also global state in disguise, which is why it's so hard to test. The pipeline is fixed. Fetch, build, deliver. Only one step is left open. Which document to create? A PDF subclass fills that hole one way, a CSV subclass another, and the caller never learns the concrete type. One step up. You don't pick a product, you pick a family. Switch the factory and the button, input and toggle all change together. A mismatched set becomes impossible. The catch, a new product type means editing every factory. Each call adds one part and hands the builder back. Optional steps get skipped, the order stays fixed, and the finished object only exists after build. Reach for it when a constructor has grown 8 arguments, half of them optional. Rather than construct a new enemy, copy one that's already tuned and change the field you care about. The expensive setup comes along for free. Just be certain whether your copy is deep or shallow. Structural patterns. How objects get wired together without being fused together. Your code speaks money objects. The gateway speaks integer cents. Nothing fits until you drop one object in between that knows both vocabularies. Neither side changes a line, that's the whole pattern. 9 classes because shape and renderer got tangled into one hierarchy. A 4th renderer would cost 3 more. Split them apart, joined by a single reference, 3 plus 3, and that 4th renderer now costs 1. Inheritance multiplies. A reference adds. Call size on the folder. It asks its children, they ask theirs, and the totals add up on the way back. A file answers the same call a folder does, so the caller never checks which one it's holding. A core handler. Retry wraps it, caching wraps that, logging wraps that, and every layer implements the same interface, which is exactly why they stack in any order. You pay for it later, reading stack traces with 10 frames all named handle. Behind the door, 6 subsystems and the exact order they have to fire in. In front of it, one method. The mess doesn't go away. It just stops being every caller's problem. Watch that it doesn't quietly become a God object. 24,000 trees. Each one stores position and scale, 12 bytes, and points at a single shared mesh. 96 gigabytes becomes 4 megabytes. The one rule, the shared part must be immutable, forever. The caller thinks it holds the image. It holds a stand-in with the same interface. First call, the proxy loads the real object. Second call, it answers from cache. The real object never wakes. Lazy loading, access checks, caching. Behavioral patterns, 11 of them. Who talks to whom, in what order, and who gets to decide. The request walks the chain. Auth passes it on, throttle passes it on, cache passes it on, the router handles it. Each link knows only the next one. Reorder them and the behavior changes with no edits at either end. Toolbar, menu, and keyboard shortcut all produce the same object. Bold, with a do and an undo. Push it onto a stack, and undo becomes walking that list backwards. Every command you write owes you a correct undo. 2 plus 3 times 4 becomes a tree where each node knows only its own rule. Multiply gives 12, add gives 14. The rarest pattern in the book, unless you've written a filter DSL, in which case you've already used it. On the left, a tree. On the right, what the caller sees, one flat sequence. Swap that tree for a paginated API tomorrow and the loop is untouched. Your language already built this one in. 6 components, 15 wires, everyone importing every other. Route it all through a hub, and it's 6. The complexity doesn't vanish. You moved it into the hub deliberately, where you can actually see it. After each edit, the editor hands out a sealed snapshot. The history holds them, but can't open them. Only the editor can read one back. That's undo without making your internals public. Snapshots are memory, full copies get expensive. The order is paid. It publishes to a list it never inspects. Receipts, ledger, and search index all react. A listener can unsubscribe at runtime and the order never knows. The cost is a call graph you can't read from the code. One button, one method, press. But the outcome is play, pause, or replay because the object swapped its own behavior underneath. Each state is an object with its own version of every method. Draw the machine, or you'll lose it. Same caller, same input, same output. Only the algorithm in the slot changes. Quicksort, merge sort, counting sort. In a modern language, this is usually just a function parameter. Don't build a class hierarchy for it. The base class owns the order of operations and marks two steps as blanks. CSV fills them one way, JSON the other. Steps 1, 3, and 5 can't be touched. Strategy does this with composition. This one bets on inheritance. The node classes are closed. Instead of editing them, you write a visitor that walks the tree. One returns areas, another exports SVG, the node's untouched. A third operation costs one new class. But a new node type means editing every visitor. Patterns are names, not instructions. You don't apply them top-down. You notice one has already grown in your code, and now you have a word for it. That's the whole value.